Hello and welcome to our next geometry lesson on volume of pyramids and cones. Last time we talked about prisms and cylinders. Today we're going to be talking about volumes, the pyramids and cones, and it's a very similar formula with one small exception. We do have a fraction to work with. So as we know, volume is a three-dimensional, this the space amount of space that a three-dimensional object occupies within in cubic units. So we are actually calculating volumetric as opposed to surface area. So volume of a pyramid. So let's say do volume, let's actually write it out, of a pyramid can be drawn. So let's draw one with some kind of rectangular base. Let's draw a vertex, and then that vertex connects to all of the corners of the base. So here we have a pyramid. And that one doesn't look great, so I'm just going to reconnect this. And there we have it. So here we have a pyramid. We need to know a couple things. We need to know the area of the base, just like how we had before. So I'm going to say this is equal to I'm going to leave some space here. Area of the base. We definitely still need to know the altitude. So once again, an altitude goes from the vertex down to the center of the base. All right. So we have our altitude. And then we have our base. This is a rectangular base or a square base if it is a square. Except this time, well, right now this equation would represent a prism or even a cylinder because it's the area of the base. But we now have a 1/3 that gets thrown into this. As opposed to 1/2 like it was for slant with surface area, it's a 1/3 because volumetric is very different. Okay, so 1/3 area of the base times the altitude is our equation for any pyramid that you have, whether it's hexagonal, triangular. If you could find the area of the base, multiply it by 1/3 times its altitude, you are in very good shape to go. Okay, same thing goes for cones, volume of a cone. The difference is we know what a cone is, so it's still the exact same equation. 1/3 area of the base times the altitude. But this time around, we know what the base is. We know the base is a circle, and the area of a circle is pi r squared. So we could take 1/3 pi r squared times the altitude. So this is your more specified version. Obviously, these two equations are the exact same. If you want to remember that, that's awesome. That is a perfect way to think about it. But we know that the area of the base of a cone is a circle, so we can do pi r squared instead. So let's draw one out. And I'm going to draw a point at the top, connect it to both ends to make it appear as if it is some kind of cone. Erase some of this back end because we physically can't see it. And then let's fill in some values. Let's actually calculate something here. We should be able to tell, let's do here, a radius that is equal to, let's say 5. And then let's actually go with a slant height. The slant height here would be equal to 13. But we don't need the slant height, we need the altitude. So in order to actually calculate this, we should use the Pythagorean theorem. Or even better, if we remember our Pythagorean triples, this becomes a 5, 12, 13. So we could actually calculate this now. Volume is going to be equal to 1/3 times the pi r squared. So pi times 5 squared times the altitude of 12. Okay? 5 squared is 25, so this is 25 pi. 1/3 and 12 simplify to times 4. So 4 times 25 is 100. 100 times pi is our volume. There's no units here, so we can say units cubed. And here we have it. There's our volume of a cone. You do the same idea for volume of a pyramid. As long as you have the altitude and the area of the base, you are in good shape. All right, that does it for volume of pyramids and cones. If you have any questions, please let me know, and I'll see you in the next one. Bye.